Graph and tangent. So there's different ways to do this. I want to try this a different way to try to match more of how I like to try to help students understand how to graph sine and cosine. And so here we go. First to start out, we got to take out this 2 right here. I mean, there's 4 different numbers that can act on a tangent function that will change the way the function looks. There's the a that multiplies the tangent. There's the b that multiplies to the x, and the h. The h moves or shifts the function horizontally. It's also known as a phase shift. And the k moves the function up and down. That's a vertical shift. The b changes the period of the function, and the a usually is what changes the amplitude, but tangent doesn't have an amplitude, but a still does change the function. And I could talk about that once we graph the points that it does change. Okay, so we're going to have to take this a or this b out of the parentheses here. We're going to factor it out so that it looks more like this, so that we can clearly see what the phase shift is. So when I take the 2 out, this is what it looks like. We get pi over 6 when we divide pi over 3 by 2. When you guys divide by 2, it's the same as multiplying by 1/2. And that's actually an easier way to think about it when you have a fraction. So if we're multiplying this by 1/2, you get pi over 6 because 2 times 3 is 6. Now, I want to think about tangent and how it looks on a graph that goes from 0 to 2 pi. So when we do that, there's 2 asymptotes because their tangent is undefined at 2 different points on the unit circle. If you think about it, tangent is y divided by x. Here, let me write that down. And since there's division, anywhere x equals 0, tangent would be undefined. And there's 2 spots on the unit circle where tangent, or where x would equal 0. And that is right here and right here. So at pi over 2 and at 3 pi over 2, tangent would be undefined. And so that's what these 2 asymptotes are there for. And then when we graph it, when we pick some points, this is what our function looks like. Okay? What's really neat and nice is that these points right here that I picked, they are nice points. They come out nicely on in the unit circle. If you want to see how I got those points, go watch the other video about graphing tangent to learn more about that. So something to point out about tangent is that the period isn't 2 pi. The period of a tangent function, a regular tangent function, is pi. It's where the function starts repeating. So if you guys were to look at the asymptote right here, from this asymptote to this asymptote, that distance is pi. The distance between this x-intercept and this x-intercept, that distance is pi. Every pi spaces, every pi distance, tangent repeats itself, and so that's why it's known as a periodic function. So here, because we have a 2, we're going to take the normal period, which is pi, and we're going to divide it by the b, which is 2. That's going to be the period for this tangent function. And so we get pi over 2. The phase shift is obvious. It's right there. And since it says plus pi over 6, you got to think moving left. And so I'm going to say negative pi over 6. And then I'm going to make my cheat graph. Now, because tangent is only has a period of pi, we don't need all of this to be our mother function, the parent function that you're shifting for whenever you have like an a, b, h, or k. So we're going to take out half of it so that we just have a pi distance right here. So this is going to be our mother function, and that's what we're going to make our cheat graph look like. I put my x value negative pi over 6 right here because that is our phase shift. And now I'm going to put my asymptote. Asymptote goes right down the middle. This is what we got right here. And then I can graph the rest of it without doing my x values. But we'll find my x values in a second here. So we got this curve right here that matches that. And then we got to put the other curve right here to match that. Oh, how are we going to find the rest of our x values for transferring this over to our scaled graph? The way we're going to do that is the distance from this point to this point right here, we know is pi over 2. And so, but we have to count 1, 2, 3, 4 spaces. And so we're going to take pi over 2, and we're going to divide it by 4. That's the same as multiplying it by pi over 4. We get pi over 8. But when we look at where we start at negative pi over 6. So we got to have the same denominators so that we can add them together very, very simply. So 8 and 6 have the common denominator of 24. I had to multiply 8 by 3. So I have 3 pi over 24. And pi over 6, negative pi over 6 would be the same as negative, let's see, that would be over 24, negative 4 pi over 24. So that means this x value right here would be negative pi over 24. This x value right here, where our asymptote is, would be 2 pi over 24, which can be simplified. Let's simplify it right away. We have pi over 12. And then if I add another 3 pi over 24, this x value would be 5 pi over 24. And then finally we get to 8 pi over 24, which can also be simplified by dividing top and bottom by 8. We get pi over 3. So because this tangent function only has a 2 and a pi over 6 changing the mother function, we don't have an a, well we do have an a, it's just a 1, and we don't have a k, so we're not shifting up and down. That means our midline is going to still be at 0. This point right here is going to be at 1, and this point right here is going to be at negative 1. Now these points right here, these are what would change if we had an a. If like a was 2, this point would be going right here, and our curve would look like that, a little bit more stretched out. If a was negative, then instead of the point going right here above the x-axis, it would go below the x-axis, and the curves would flip. Okay, same with this one. This would go up here, and it would go like this. So since there are no other changes, I can go ahead and transfer this graph over to my scaled graph. Now we can't graph this point or this point onto our scaled graph because we're starting at 0. We would just see an arrow. So let's graph our asymptote right over here. We know that this is counting by pi over 6s. And so if we wanted to find pi over 12, we would have to go right in the middle of 0 and pi over 6. So that is where my asymptote is, my first asymptote. 5 pi over 12 would be 5 pi over 24 would be a hard point to find. But the next point, which is at pi over 3, is not hard to find. So I'm going to go ahead and graph that. That would be right here. And that means between, right in the middle of this one, this guy and this guy, that's where we're going to find 5 pi over 24. So we're just going to put a line right in the middle of those two, and I'm going to go down to negative 1 and graph my point. And then I think that's the rest of this would make it easy to graph the rest of this if we can just get the rest of our asymptotes. Now our asymptotes are going to be pi over 2 distances away from each other. Now for the next asymptote, I'm just going to kind of guesstimate, because if this was 0 and this is pi over 2, like that's your distance, and that means this asymptote, the next would point us to the next asymptote would be right about there. And so I'm going to go ahead and put my asymptote right there. And then I'm going to do the same thing and put another asymptote right here. All I'm going is half of pi over like that. Now I'm going to do that again, and I'm going to have an asymptote right here. And then because I have my asymptotes, I can easily find my other 3 points that are between each asymptote so that I can get the way my function looks. So right in the middle between the X-intercept, or I can say the midline intercept, and my asymptote, we have a positive 1. And we have our first curve that we can draw for tangent. And then for the next one, I'm going to go right in the middle. I'm going to go to the left in the middle and go down 1. I'm going to go to the right in the middle and go up 1. And there's my next line. Okay, I'm going to keep doing that, just copying it. And there you have it. There's the rest of my graph. Okay, let's do the range really quick. The range is negative infinity to positive infinity. You have arrows pointing up and down, so we're just going to put negative infinity to positive infinity to be done with that. Our y-intercept is not very easily seen. It looks like this line right here is going to intercept our y-axis. Our y-axis is going to be right before this guy, but I don't know exactly where it's going to cross over, so we're not going to worry about the y-intercept because that would be difficult to find. We'll have to use some algebra and trig to find it. We're going to go over to the x-intercepts. The x-intercepts are easy. They're right here in the middle. We can start at this first one and just keep adding pi over 2 to find our other one. First x-intercept is pi over 3, and then I'm going to add pi over 2 to it, which is with a denominator of 3. Oh, it's not, can't have a denominator of 3, so I'm going to have a denominator of 6. So we have 6 on the bottom and 3. So we're going to add 3 pi over 6 to this to find our next one. I have to do it 1, 2, 3 times. So add 3 pi over 6 to get 4 pi over 6, which can be simplified. I add 3 pi over 6 again, which is 7 pi over 6. That one cannot be simplified. And then I add it one more time, 10 pi over 6. That one can be simplified. I'm not going to simplify it right now. I'm just going to leave it like that. More generally speaking, I could just say pi over 3 plus pi over 2, because that's my period, n. We can add as many pi over 2s or subtract as many pi over 2s as we want, and we'll keep finding new x-intercepts. And that's kind of like what I'm going to talk about for our asymptotes also. First asymptote is at pi over 12. I'm going to add pi over 12, but I need to have a denominator of 12, so I'm going to multiply the top and bottom by 6. So I get 7 pi over 12, and then the next one would be 13 pi over 12, and the next one would be, what is that, 19 pi over 12. Now I have four asymptotes. No, it looks like, yeah, there's only 4 asymptotes. This one's after 2 pi, so I don't have to write that one. And more generally speaking, what I can do is I can just write pi over 12 plus pi over 2 times n. So adding and subtracting as many pi over 2s as I want to find my other asymptotes. So this is what the asymptotes would equal. And that's it. This one had a period change and a phase shift.